This is a follow-up video to my video on moles and molar mass and mass calculations, and it's one that's specific more to Avogadro's number. So I'll just quickly review the concept of a mole. A mole is not like this guy here. In chemistry, a mole is defined as a really big group of particles. And Avogadro's number is that huge group of particles. So a pair would represent 2, a trio of things would be 3. We talk about a dozen being 12. A score of arrows would be 20 arrows. And in chemistry, when we talk about a mole of atoms, we're talking about 6.02 times 10 to the 23 atoms. And that number is known as Avogadro's number. So that's how we will convert from number of particles to number of moles. And we could even convert from mass, using mass and moles from our previous formulas, and tie in Avogadro's number into there as well. So let's look at a few examples and see how this is going to rear its ugly head at us. So if we have an example of if you had 35 moles of nickel atoms, how many atoms would you actually have? So the math is not that tricky. We have 35 moles, and Avogadro's number tells us that you have 6.02 times 10 to the 23 atoms or particles for every 1 mole present. So the simple multiplication, if you set your factor labels up like this, you would have moles that would cancel, 1 in the numerator, 1 in the denominator. It really says take 35 moles and multiply by 6.02 times 10 to the 23. So we'll bring up the calculator and type that in. So we want to take 35 moles, we'll leave it right where it was. So 35 moles times 6.02 times 10. Well, let's get rid of this thing so we can see what we're writing. So the exponent, 23. So don't hit multiply 10 to the x button on your calculator. You've got a EE or an EXP button on your calculator, so use that instead. Okay, so 6.02 times 10 to the 23, and you get 2.107, we'll call it 2.1 times 10 to the 25 atoms. So 2.1 times 10 to the 25 atoms. Now that is an unimaginable amount of atoms. It is huge, right? To think of 2.1 and then adding, or not even the decimal, but 2 and a 1, and then 25 zeros on there. Whole bunch of them, or 24 zeros to be precise. So it's a monstrous, monstrous number of atoms. Okay, so let's look at example 2. Let's say you had 4.0 times 10 to the 23 atoms of gold. How many moles would that represent? Well, we're going to use Avogadro's number, but instead we're going to invert it so that we can use it by dividing instead. So if I took my 4.0 times 10 to the 23 atoms, in this case, if we set our fraction up upside down and have 1 mole representing 6.02 times 10 to the 23 atoms, then when we work this out, you could take the atoms on the top and atoms on the bottom would cancel. So we'll bring the calculator back up, and this time you're going to take 4.0 times 10 to the 23 and divide by 6.02 times 10 to the 23. So the calculator, we're going to take 4.0 times 10 to the 23, divide by 6.02 times 10 to the 23, and that gives you 0.6644. Well, you notice you just wasted a lot of time in your calculator typing in times 10 to the 23 in the numerator and times 10 to the 23 in the denominator. It's the same thing. Why would you waste your time typing that in? Instead, type 4.0, divide by 6.02, and guess what you're going to get? The exact same answer. Save yourself the keystrokes, use your brain a bit instead, and save yourself some time as well. So 0.6644, 0.66 moles. So not quite 1 mole. You've got 2/3 of a mole there. All right, so last example. If you had 25 grams of silver, how many atoms would that represent? Okay, so we have a mass, 25 grams. That's our mass of silver. When you look up the molar mass, I'm going to use symbols like and the formula that I used in my moles video. The molar mass for silver is 107.87 grams per mole. And this question, we're first going to figure out how many moles do we have, and once we know the number of moles, n, then we'll get how many atoms that is. Okay, so to get the number of moles, we take mass and divide by the molar mass. You take grams and divide by grams per mole. So 25 grams divide by 107.87 grams per mole is going to give us a number of moles. So bring up the calculator, and you get 25 divided by 107.87 will give us 0.23. So 0.23. That's a number of moles that we have. Okay, so 0.23 moles. Now, just like our example above, in the first example, if you want to convert moles into a number of atoms, then we're going to take this number of moles, 0.23 moles, and multiply it by 6.02 times 10 to the 23 atoms per 1 mole. So by taking our answer and multiplying by 6.02 times 10 to the 23, it's going to give us the final answer to this question. So take our answer that we have and multiply by 6.02 times 10 to the 23, and that'll give us 395, so 1.4 times 10 to the 23 when we round this off. So 1.4 times 10 to the 23 atoms. Okay, so to do this question, we had to first work out, turn grams, we had to convert grams into moles, so we use this formula to do that. So 25 grams became 0.23 moles. Then we took 0.23 moles, multiplied by Avogadro's number, and we got the number of atoms as 1.4 times 10 to the 23. This should give you lots of guidance to be able to solve Avogadro's numbers questions in terms of how many atoms and moles. Hope this works out well for you.